parallel if they are what?
Ratios of each other.
Okay, those are all sentence fragments. Give me a full sentence.
Well, one is the scalar.
Scalar multiple. They are scalar multiples of each other. Something. If A is a scalar multiple of B, it's the same the other way around. So what do we got here? We have T is the value we're trying to determine, right? So we have. Let me write this out. We have. You wanted to go to B, is what I heard.
Yeah.
Ti plus j plus t minus 1k, and you want that to be parallel to 2i minus 4j plus k, like this.
Yeah.
So scalar multiple means that the ratio of the corresponding coefficients, the components, needs to be constant. It has to be the same, right? So you know that t over 2 has to equal t minus 1 over what? Well, the coefficient, this coefficient right here matches up with this coefficient right there. So what's the other pair? T minus 1 has to match up with 1. So it matches up with 1. So that implies that t is equal to 2 times t minus 1. So t is equal to 2t minus 2. So you end up with negative t is equal to negative 2. So t is equal to 2. Does that make sense? The ratio has to be the same.
No, but then the ratio.
Oh, but there's a third one, isn't there, right? So there's a third one? Okay, got it. So the other thing oh, I see what you're saying. Got it. Oh, look at that. So what's the other ratio there? 1 to negative 4, right? But that does not equal 1 over negative 4. So what do you think the answer is there for? There's no such value, yeah. I think that's possible. They didn't really directly imply that, but I don't see any mistakes there. It's about as clean as it gets. So it does. I mean, usually they say something or say it's not, but they don't. So like usually that either means you made a mistake or the answer is some trivial answer like 0. Like the 0 vector is parallel to the 0 vector, and you're like, great. But no, in this case, it obviously there is no value between. It's really fun. So what do we have here? V is equal to what? 5i minus 7j. And then for A, it has draw a position vector for V equals 5 minus 7j. So what does that mean? You're going to go over how much? 5 to the right, and then down how much? 7. So you go over 5, and down 1, 2, 3, 4, 5, 6, 7. So the vector you're looking at, I'll use the nice one like this, is right here. Like that? Okay, sounds good. What is the magnitude? Square root of what? Yeah, 25 plus 49 is going to be the square root of, I think 74 is prime, right? 74 prime? Mm-hmm. Yeah, I think it is. Is it prime?
It's not
it's almost an even number. Wow, man, is it frozen. I'm like deeply thinking, like, the answer seems like it's right in front of me, and yes, that is recorded. Awesome. Thank you for posterity. You're fun. Good at math, Mr. Seaman. Okay. Find the angle between V and the positive x-axis. So what's the positive x-axis?
There.
It's right there. It's what I wrote the 5 on right there, right? So you have to find this angle value. So how do you do that? Yeah, you can use any trig function you want.
So does it have to be degree or?
In general, we like working with radians in general, but in this case, since it's not specified, you could use angles. That's fine. Anybody have an angle measure for this one?
In radian?
Either one. Just tell me what you got.
0.9.
You got theta, alpha is equal to what?
0.9.
951, something like that. We like 3 decimal places out of our time in AP land. Yeah.
Oh, so that's fine.
That's fine. That's fine. Yeah. There's no. More vector introduction. What's nice is that many of these vectors you've seen before. So for example, the velocity vector of a moving object is a vector whose magnitude is the speed of the object and whose direction is the direction of its motion. How many people have dealt with maximum speed? Yeah.
9.
And that would happen when? That would happen if what is going on? If what?
If the boat and the currents are going in the same direction.
If the boat and the current are going in the same direction. If they're not going in the same direction, it's not going to be 9 kilometers an hour. What's the minimum speed it could be going?
7.
7. It could be going exactly against it. So all you know, given this information, is that with respect to land, the boat is moving somewhere between 7 and 9 kilometers an hour. Does that make sense? So if you were to draw this for number 2, if you were to draw what was going on, you have your velocity vector here of your boat, v, and then tacked on to the end, you have your current. Do we have any idea what direction this current is going in?
No.
We know that. What's the magnitude of v? 8.
Theta.
It's 8, I think, right? Was it 8? Yeah. So you tack it on here, and here's the current C right here. But what direction could it be going in? Any direction. So it could be going backwards. It could be going, this way. It could be going that way. The point is, the actual land speed, the speed with respect to land, is going to be what you get when you connect here and the terminal point for C. That's it. Nothing more.
The components.
The components, right. If you are given what about the direction? The angle, right. So sometimes you just know an angle and you need to come up with like the horizontal and vertical components. And how many people have dealt with something like v cosine theta and v sine theta before? Like physics, right? Yeah, exactly. You've done these things before. Does everybody remember what is this? Remember this a little bit, right? So for example, what does that mean sine is? Opposite over hypotenuse, right? Opposite over hypotenuse. So if you wanted, let's say this side was y capital, well, let's not use the same variables. So let's say b and a. So you know that sine of theta is equal to what? B over what? Yeah, you got it. B over what? V. And in this case, what is V is we've labeled it. The challenge here is that we have V cosine theta. Is V a vector right here? Is this V right here a vector?
No.
No, it's what is it? It's magnitude, right? So you have to be just kind of careful about. They're being a little lazy with the notation right here. It'd be a little better if there were like bars and the little hat over it. Like V by itself, you're like, what? Anyway, the point is this is where it comes from. So you know that V sine theta is equal to, right? And you can do the same thing for it. I mean, there's nothing to agree upon. What does it mean when the theta value is pi over 6?
Radian.
It's in radians. First of all, yes, it's in radians. That would be a terrible way to make a math question harder.
Respective to the x-axis.
Respective to the positive x-axis, right? In which direction are you going? Counterclockwise, right? So our standard angle measurement is going to be positive, counterclockwise from the positive x-axis. We don't want to set anything else. We just have to set it, okay? So we're going to set this thing up. So what are you looking at? You have pi over 6 from the horizon. What is pi over 6 in degrees?
30.
30 degrees. So we have 30 degrees. And what's our magnitude of this vector here? 2. Nice. So if we want the vertical component, what is that? What is it? Well, can you give me a little bit, work backwards a little bit for me? Yeah, 2 times sine of what? Thank you. And what is this going to be? 2 times?
Cosine.
Pi over 6, exactly. And we know that this is going to be 2 times a half, and this one's going to be 2 times what? Root 3 over 2. So we have root 3 and we have 1. So if you had to resolve these into the components, what would this be? You now know that vector v is going to be equal to, what's one way to say it now? Root 3 I plus j, like this. Exactly. Right. Sure. That's all we're going to do here. You are going to resolve things into component vectors a whole bunch. So this right here, this trues into like v sine theta and v cosine theta. It's just going to be this automatic. 2 minutes left. So now that I'll go on the record. So yeah, you're going east. Good job. 600 kilometers an hour. Nice. And then tacked onto it, what do you have? This little northeast one, right? At 50. So is its ground speed going to be greater or less than 600? Greater. It's going to be greater, right? So how did you guys go about doing this one? So you're trying to find information about this vector right here.
You know it's 45 degrees.
You know it's 45 degrees because it's northeast, right? So how did you go about finding, for example, the magnitude?
You had to use
component in the y component, yeah. So do what I was trying to do, which is in the wrong direction. You have 600, 0 for one vector, and what's this one going to be?
50 over root 2.
50 over root 2, comma?
50 over 2.
Exactly. Very good. So what can you do? Can you find this? Let's call this one vector c right here.
Exactly.
Well, you don't need Pythagorean yet, but just like what is vector c going to be? 600 plus
Plus 50 cosine.
50, I'm just doing this right now, and then comma 50 over root 2. So if you want the actual speed, can you now do the magnitude of that?
Yeah.
Yeah, absolutely, absolutely. So now how can you find the angle measure?
Whatever. Trig function.
Whatever trig function you want. You have the x and the y, so maybe you should use what? So you have tan inverse of 50 over root 2 over what? 600 plus 50 over root 2. Yep. Yay. Okay.